Hello everyone, welcome to the CFD College. I'm Ashkan, and as you know, in this course, we are talking about CFD Post module in ANSYS Workbench. This is the second tutorial. In the first one, we introduce this software, and in this tutorial, we are going to uh, add some results, import some results in CFD Post. We are talking about how we can display our geometry, and in the end, we will create some points, lines, and planes. So let's go to the CFD Post. This is my CFD Post. I'm working with standalone CFD Post, so I need to import my data and my results first. So I can go to File and then click on Load Results, or I can simply use this shortcut, Control plus L. After that, you will uh, see this window. You should go to your directory and select your uh, data file, for example, Fluent Data or CFX RES file or something else. So let me uh, choose my directory. This is my directory. As you can see here, I have a Fluent case and I have Fluent data in this directory. Uh, the thing that you should know is you just need to select the data file. You don't need to select both case and data files. Only the data file is enough, but make sure that the case file is in the same directory as the data file. So I click on the data file and then I click open. Uh, it will take some seconds. Depends on the volume of the data and the number of mesh cells. So after that, you can see the wireframe of your geometry. In the outline tree, you can see there is FFF2 00591.dat, which is the data I already imported. So this is the computational domain, and these are my boundary conditions. As you can see, I can check them, check these boxes, and you can see the surfaces. You can simply click on the screen and I mean the left mouse button, and rotate the uh, domain and the geometry uh, to get the best view that you want. Uh, a CFD Post is a good software uh, for us to, display our geometry, our computational domain, to take some photos and pictures of the geometry and put them into our papers or reports. So you can use it, and you know that you already saw. Uh, it's so easy. There are some details you can change by double clicking on each boundary. For example, if I double click on wall inlet is this surface. Uh, Here in the details section, you can change the color. You can change the color and click on apply. It's so easy. You can click on this button to pick any color you want. And maybe the best setting is in the render tab here. You know this render and view, these two tabs, you can you will see them in every command and component that you pick. So I explained them once here, and then we just use them in another, commands or components. So in a render tab here, you can show the mesh lines, for example, by clicking on by check this option, show mesh lines. If you check this, then click apply, you can see the mesh lines. Let me apply it to the other boundaries. See, you can show your mesh here, uh, and it's better actually to change this transparency. For example, for one inlet, I always change it to 0.9, and actually the other ones, to get the best view of the domain. You can change, oh, this one for inlet, for example, 0.5, and for outlet 0.5. You can show the mesh lines on inlet and outlet. You can increase the line width, the mesh line width, which is good. You can change the color of the mesh lines. The default is black, as you can see, but you can change it. Uh, Let me choose default. So as you can see here, CFD Post is a good software to display the geometry. You can choose different colors for each boundary to get the best view. And so it was the render tab, and under the view tab, you can add some views. For example, not in this case. For example, when you have a periodic geometry or a 2D symmetric geometry, you can show the other half of the geometry, show the full model using these tabs by applying rotation or reflection or mirroring. Uh, I think I can't apply this geometry, but in the next examples, we can see these options. Actually, these options are available on default transform. You can double click on default transform and change the view of your uh, domain. As I said, if you want to get the full domain of a periodic geometry, or if you want to see the other half of a symmetric 2D or 3D uh, domain, you can use these options. But as I told you, in the next tutorials, we will check it. Okay, after uh, displaying the geometry, it's time to create some points, some lines, and some planes. If you go to insert, locations, and then locations, you can see you can create point, line, plane, volume, isosurface, isoclips. We will discuss isosurface and isoclip in the next tutorials, but in this tutorial we will talk about point, line, and a plane. So you can find them here as well under the location tab, point, line, and plane, and so on. So if I click on point, if you want to create a point, for example, to export the pressure, the velocity, or other parameters on that point, you can simply click on um, create point, and you can specify a name for it, and after that click on OK and see the details tab. Okay, as you can see here, the render and view tabs are here, but in this, I think on points there are useless, I think. But under the geometry tab, uh, there is the method of definition. You can specify the coordinates. This is the first method, x, y, and z. You can specify the node number, or you can find the point that some variable is a minimum or maximum. So it's a good thing. It's a good option for us to find, for example, where we have the minimum velocity in our domain, where we have the maximum temperature. So the first method is specifying the coordinates. You can specify the coordinate that you want, for example, for x, and you can also see uh, here the coordinates here. So for x, I will choose 0.3, and for x and y, I leave them at 0. Yeah. I click on apply, and you can see this is the point. Here, there is a point which is added to the outline tree. You can uncheck it or check it to display the point to see if it's in the right location. Uh, you can change it, and here you can see the nearest node number. You can see this is the number of the node which is near this point. You can create lots of points. Let me create another one, point 2. I will put 0.4, 0.01 for y, and 0.01 for z. Here this is our a new point. The second method is rarely used because you know usually we don't know the node number of our points in our domain, but the second and fourth options are so useful. As I told you, for example, variable minimum, if I choose, I can see the minimum, for example, pressure or any other parameter, for example, velocity. Let me choose velocity, and you should specify the location. For example, I want to see the location of the minimum velocity at the inlet. So if I apply, uh, you can see there are many points because at the side of the inlet the velocity is 0. So let me change it to pressure. So here, this is where the pressure is minimum, at the middle of the inlet. You can specify, uh, you can choose, any location, any variable that you want. You can choose variable maximum to find where for example, the pressure is maximum at inlet. So it's obvious that the pressure is maximum at sides of the pipe. So actually, you can change the symbol, its size, for example. Now you can see it's much smaller. The type of the symbol, now we have a ball. Maybe it's the better. Yeah, it's better, I think. You can change the color if you want. And I think that's it for the point. Yeah, let's go and create some lines. So under the location tab, if you click on line, you can specify a name for your line and click on OK. Under the geometry, under the details tab, under the geometry, you can see the method, which is one method with 2 points. So you have to enter 2 points, which is the start and the end of the line. For example, mm, let me change the x coordinates of the second point here, and the first point is at the middle of the inlet. So if I click on apply, you can see the line that I created. It's in the middle of the small pipe. It's actually the center line of this pipe. You can choose any coordinates that you want, and you can change the color of that line. And there's also a good option here, line type. It has two different types, cut or sample. We usually create lines to extract data or to create some charts and plots on that line. For example, the velocity of the x velocity on this line from the beginning of the pipe until the end of the pipe. So if we choose sample, we can specify the number of samples that CFD Post should extract data on. If I choose 10, this line will be divided to 10 sections, and you can extract at that 10 points any data that you want. But if you select cut, the CFD Post will show you the results on mesh nodes, which are on this line. So if you have a fine mesh, maybe the cut type is useful for you, but if you have a coarse mesh, the sample line will give you better results. After that, sometimes we want to create some planes. Actually, we usually work with ISO surfaces, but planes are often useful, and we use them. So let's work with that and create some planes. If I click on plane, you can specify a name for it. I click OK, and on the details tab, you will see some options for you to create that plane. Like others, we have a method. For example, this the chosen one is YZ plane. It means that we want to create a plane which is parallel to YZ plane and in a distance from it. For example, if I chose 0.1, apply, here is my plane. It's parallel to YZ plane in a distance of 0.1 meter. The same goes for ZX plane and XY plane. For example, if I choose XY plane and the offset from the origin in the Z direction is 0, you will have this section and this plane. So these are using these three methods, you can create planes which are parallel to XY, XZ, and YZ planes. If you have a point and the plane normal, you can choose this method. You should specify a point and the normal of the plane that you want, And if you have 3 points, you can create a plane using 3 points in the last method. Uh, the plane type is like what we had in line. You can create the plane by samples, and you can specify the number of samples in each direction, or you can click on a slice and let CFD Post to extract data on nodes, on mesh nodes, on grid nodes. And here, in creating planes, slice type is good for us because we want to see, contours or streamlines on these planes, and we don't need too much of data, and we don't need to define, a large number of samples. So the slice type is good to create some planes. So that's what we planned to teach you in the second tutorial. In the next tutorials that we in next tutorials we will display velocity vectors and different contours on these planes, and we will extract data and create some plots on the lines, different lines that we have in our domain and we created. So that's enough for this session. In the next video, we will generate some contours, and we will talk about contours. So if you have any comment, you can write down in the comment section. Please like the video, subscribe to the channel if you want more videos about CFD and different software, uh, particularly ANSYS Fluent. And thanks for watching. Bye bye.